Hello and welcome to this Java tutorial. So in this video, we'll discuss one enhancement to the traditional switch construct, which is known as switch pattern matching, and that was finalized in Java 21. So switch pattern matching actually enables developers to match not only constant values, but also types and objects. Okay, one note here. As a prerequisite to understanding switch pattern matching, you should have some idea of inheritance, parent and child classes, types and subtypes, along with instance of operator. So if you don't know about inheritance, instance of operator, then you can come back to this chapter once you have idea about those topics. Then it will make more sense. All right. So coming back to switch pattern matching, so it allows actually conditional execution based on the runtime type of an object. What exactly does it mean? Let's try to understand with an example where what we'll do is the requirement is to perform formatting or do some string conversion depending on the specific type of number provided. So here this number, right? This is actually a super class for all the numeric wrapper classes. For every primitive data type, there is a corresponding wrapper class, right? Integer, double, short, byte. And for all those wrapper classes, parent class is this number. And if I have to write some logic using this parent class and I want to do something different based on different subtypes, then traditional way would be using if else if, right? And with instance of I can check what exactly is the type of this number. Is it integer or float or double? And then do corresponding formatting based on the type, right? So let's see code that will make more sense, right? How will we do it traditionally, and then we'll see how you can do it using pattern matching. So here is our example, already written it. So first thing is I have a array of type number. That means it can take any subtype, right? Can store any subtype data also. So I can have integer, I can have double, I can have float, integer again, long, even null in the same array because it is of type number. Now, when I pass this number one by one, I have a method where I pass it. Then I check, right? If it is an integer, then I want to convert it to string. For that, I use instance of to check. If it is double, then I want to format it. So I have two decimal points. If it is float, then I just write that number by adding suffix to it. Right? I add f to it. Long value again, I am converting it to string. And I have else also where I'm saying unknown number type if it is of unknown number type, and all that is included within null check. So first thing I check if it is null because I have null also here. Otherwise, I'll get null pointer exception at runtime. Right. So this is the traditional way how you will handle this type of scenario with different subtypes. Now let's see how you can do it using string pattern matching. Okay, so if I have to do it using pattern matching, first thing within this basic.condition package, I'll create a new class switch pattern demo. Right. So this thing anyway will be same, so I can take from here itself this main method. Then what I'll do, I'll actually copy this also. Within this, I'll make changes. All right, let's not call it traditional. This is the new way to formatting pattern. Call it that pattern. So I'm getting number still, each number from this array. So now how I can do it? You have to switch on this n. Then I can write different cases. Case integer I. Then what you want to do is right like this. I can write case integer I Then do what? Same way, case double t. Then what do? You format it. So I can bring here. Then I have case float f. For that, we just add suffix and case long l. And best thing is now there is also a case for null. So you can write here itself. Data missing. And for else, we can use default now, right? Default unknown number type is n. So that is how you can do it now. You can make a comparison here itself. No instance of needed. It will directly bind it to the correct type based on what exactly is the subtype here. 5. That means it will come to integer. 6.78, it will come to double. You don't need to do a explicit check using instance of. That will be done by Java runtime itself. Right? That is one thing. You don't need this null check. You can just write case null now. So let's remove this part and run it. And if you see, we are getting it. Integer as string 5, double formatted, float with suffix, integer as string. So this is again taken as string 90. This is going to long because it has L and it is a long value actually. And for null, it is going to data missing. Right? And if you compare it with this, obviously this is better, much concise. You don't have a lot of boilerplate code for type checking, and null also is coming here itself. So these are some of the benefits with this new switch pattern matching, which is finalized in Java 21. What switch pattern matching can do? We have already seen what it can do. Let's go through it in some details. So switch directly on object types. That is one benefit. That is what we have seen also. Now we can switch directly on types of object, right? With switch statement, you could only use primitive values or enums or string. Now you can use object types also. So here is another example. Suppose I want to find the perimeter of the passed shape. So shape is a super class and two child classes, rectangle and circle. Now with the new pattern matching, I can write it using switch case very easily. I can switch on shape object. Based on the subtype, I can apply the correct formula, right? So it can be done easily with pattern matching like this. Then variable binding automatically binds the matched object to a variable. So here you see, right, is automatically going to the correct type. For 5, it is going to integer. For this, it is going to long. For this, it is going to float. So that is done automatically. So you don't have to check using instance of, and if needed, you don't have to do any typecasting. All that is taken care of by the runtime itself now. Null handling. So you have case null branch also, which we have seen. So you don't need any extra check. Here we need an extra check. If we don't do that, it will give null pointer exception. Now you can give it as a case null itself. Then code obviously is shorter now, more readable. Then you also have exhaustiveness. Here compiler forces you to handle all types or use default. So we'll see all this is in detail. These are the new features within pattern matching. There is also guarded pattern where you can add condition also to the case itself. So these two things we'll see in detail now. So exhaustiveness means that you should give all the possible values. You have to account for all the possible values in case. What it means is what you are using in switch, right? Some type. So in case you have to give all the subtypes. all the values. So you have to exhaust all the possible values. Otherwise, use default. So you need to explicitly cover all possible scenarios that the input can take. For reference types, this usually means handling both null and all relevant subtypes. Otherwise, you will get an error. Let's see here itself. What we have used is this number, right? We are switching on number. If we don't use default, I'll start getting error. An enhanced switch statement should be exhaustive, a default label expected. So either you give all the subtypes. For number, there are many, I think 12 or 14 subtypes at least. These obvious one, integer, double float, long. Then you also have atomic long, atomic integer, big decimal. So there are many. Either you have to give all of them, which is not very practical, or use default as catch all the other, right? Yes, so include a default case, it acts as a catch all, which means you are satisfying the exhaustiveness requirement. That is why you should use default or give all the subtypes. Otherwise, you will get compile time error as I have just shown. So that is one requirement with switch pattern. You either have to give all the subtypes for the given object or use default for other types. Whatever is given here, if it is of any other type, then it will come to default. Then there is also one more thing which is known as guarded pattern label. Now you can add a Boolean expression within your switch case, which was not possible. In switch statement, you could only use constant values, nothing else. No conditions. Now it is possible to use a condition also using when, where this when clause is called a guard. So how this guarded pattern works is, first thing, it has to match the pattern, right? Like here. So first thing, it has to match the pattern means type, which type. Then once this type matches, then you can have a guard condition that is evaluated. And if there is a full match, that means type plus this condition, then only this guard will evaluate to true and you can execute what is given here. So suppose I want to do this only when I is greater than 0. Now I can give it like this also. Within case I can use when. Right? Right now it will work with everything as it is. Now if I give 0 here, for 0 also it is going to unknown number type. Right? Because it is not matching this. So it will go to default. Right? Does not match this. Because of this when I greater than 0. Obviously it won't match anything else, so it will come to default. So that is how you can use when. Let's try to do one example itself for this guarded. So switch guarded demo, let's name it. So let's take a scenario where I want to take the length of the string also in account. So what I can create is method public static, not returning anything, so void display message where I get object obj, right? I'm taking it as object just for type also. It obj, here I'm sending some value, let's say test. Then here what we can have is switch on this object. Within that can have a case string s when say s dot length is less than 5. Then what I do is okay, short string plus s, and this I'll call from here display message, which will get an object, right? Then I can have another one case string s, Here I don't have anything. I just whatever I get, I print it. String s. And there should be a default for that. Also, I'm getting an error. So default would be invalid value. Correct. Now if I run it, first time it will go to this one, right? Where you have string also. This is type is string. Length is also less than 5. So both are satisfied. So it is going into the first case. Now suppose I add tests, make it more than 5. Then it will go to the second one. This will fail, this will pass, right? It is still a string. So both have to be true if you have any condition. And this condition you can use and or all that also you can do. And is dot length less than 5, greater than 2, something I have to give, right? Between 2 and 5. So I can give range also like this. So that's how I can use this pattern also. Now one more thing is with this pattern, actually guarded pattern, you can also use actually primitive type Java 23 onward, but it is still a preview feature. So you need to compile your code with preview feature, then only it will work. So let me show you one example. Okay, so here is a method which is already added actually. So evaluate score. Now if you see case with primitive type int, that is why it is giving error also actually, because it won't run like this. I have to enable this preview feature, then only I can compile it and run it. Okay, so if you see case is with int where I have this, and when also with range also, so everything is there. Calling it from here, evaluate score with some score given 85, and I'll get back the result which is printed here, is returning that value as a string, right? So that's what we are doing. Better to do it with the command prompt. I can compile it using enable preview feature. So I go to the command prompt where I'm already in the Java project and source, right? Within this source, from here, what you can do is Java C enable preview, then hyphen hyphen which release. So I'm giving 25 right now, Java 25, JDK 25 I'm using. Within that, to give like this, right? Basics, conditions, that is my package. Within that, I have this class, right? Which guarded demo, which guarded demo dot Java. Okay, so it is using preview features of Java 25. It is compiled with preview features. Now I can run it. So Java, that also I have to give that it has to run with preview features. Now I don't need to give this release at least. Here again I have to give basics conditions which guarded demo. I get this right. Result good 85. 85 means it will come within this range, right? And there it is good. So it is still a preview feature. So you have to do like this by enabling the that preview. But yeah, it is in the pipeline that you can start using not only objects but also primitive types with pattern matching. Right, so that is how you can use guarded pattern. So you can have a condition also, and very soon it may become finalized and you will start using primitive types also. Now one more thing is dominance in switch pattern matching. So what exactly it means is that if you have one case label which makes another unreachable because it already covers the same or broader condition. So when will that happen? If you have parent class before child class, right? Then you may have a situation that your parent class will handle the condition for child class also. So you may never reach the code for child class. That is the dominance in switch pattern matching. So parent class is dominating the child class, right? So that is the idea. So we have this code, right? Let me comment this part to remove all the errors. Right. Now, if we come to this part, if I add one case object O and something for object. So this will take all the condition now. Everything will come to this only because it is parent of all the other classes. So you will never be able to reach this string. If you know inheritance, that is a right. So string is a object. So this will handle for string also. And that is what you are getting as error. This case label is dominated by one of the preceding case labels. So if you have these kind of situation where you use parent class as well as subtypes classes, then this should come after these subtypes. Put it here, then it is okay. But now if you see, you are handling all the cases, you don't ever come to default now. That becomes an error. Okay, so this with this code actually we have two catch-all situations. This is parent of all the classes in Java. This will catch everything, and we have default also. So we have to choose one of these, right? You obviously can't have it here because then it will be the dominant thing. It will dominate all the other case scenarios. But putting it here with default also creates a problem for default itself because this also becomes catch it all. So default will become unreachable. So what do you want? Based on your scenario in such cases, you have to choose one of these, either object or default. If we don't take default, then also it is fine. Or if we don't take object and default, anyway, this was working before also. So that depends on the scenario. Do you want to handle with parent class? Because this will exhaust all the scenarios, right? Exhaustiveness. You have string type, then object itself, which covers all the other types. Right. So these are some of the things which you do with which pattern matching. So we have dominance, we have exhaustiveness, we have guarded pattern label, and normal switch pattern with different subtypes. And we have seen how it makes your code concise, more readable, right? If you compare it with this, obviously this is much better. So that's what switch pattern matching brings to the table. Thanks for watching the video. Please don't forget to like and subscribe.